Greetings, students. Welcome back to Chapter 2, Keywords and Concepts. So we're going to talk about the difference between correlation and causation in this video. And we're also going to bring up one of the many biases humans can have. There's a bunch listed in your textbook, but this is one of the ones we're going to focus on. So first thing we need to talk about is, what is correlation? Correlation just means that there's a relationship between two or more variables, right? So let's talk about the one in your textbook, because they talk about a positive correlation in your textbook. It talks about how as temperature rises, so too do the number of homicides, as well as ice cream sales, right? Obviously, these things are not related to one another, but they kind of are. They're more related to the heat. People get angry, that kind of thing. So that's a positive correlation. As it gets hotter, so too do we get more murdery. So that's a positive correlation. A negative correlation would be something where as one thing gets, the variables move in opposite directions. So as one thing gets higher, another thing gets lower. So the example that we're going to use for our class is education. So as a person becomes more educated, as a person finishes more education, they are less and less likely to commit a crime. So a person who has completed the 8th grade is going to be, at this point where they're less likely to commit a crime than a person who's completed the 6th grade. But a person who's completed the 12th grade is even going to be less likely than that person who completed the 8th grade. Okay, so as one variable goes up, the other variable goes down. So that's the difference between positive correlation and negative correlation. This is different than causation, and your textbook does a really good job of explaining this. But just in case you didn't quite get it, just because two things are correlated does not mean those two things cause one another, right? So here's one of my favorite examples for causation and correlation. We can prove that you are more likely to get cancer if you eat oatmeal in the morning than if you eat a sugary breakfast cereal. Now, I know what you're thinking. You're thinking, Professor, that sounds crazy. Eating a sugary breakfast cereal in the morning isn't good for you. That's going to give you cancer. Well, it's not about the breakfast cereal. It's about who eats the breakfast cereal, right? So in this particular example, the reason you're more likely to get cancer if you eat oatmeal in the morning is because more adults eat oatmeal in the morning. Kids have a tendency to eat sugary cereals. So yeah, you're going to find that there's going to be a higher portion of people with cancer eating oatmeal in the morning than those eating, Fruit Loops or whatever, because they tend to be 8, and 8-year-olds tend not to get cancer. So that's a good example of how correlation does not equal causation. So just keep that in mind. And then finally, let's talk about this confirmation bias here, because this is a really common one. And this is the idea that we have an idea about how something works. We then look for evidence to support that idea and ignore any evidence that could possibly tell us we are wrong. Okay, I know if you think about this for a couple of seconds, you will think of examples of this. Actually, a great example would be flat earthers, right? Everybody on the planet knows the earth is round, right? But they are so convinced that they look for the evidence, right? They look for the evidence that tells them the earth is flat, and they ignore the evidence that the earth is not in fact flat. So that's a good example for that one. All right, I'll see you guys in the next video.